Here the title is Linux servers. More specifically though, we're going to look at services or programs that are running, providing services to clients. So servers essentially are just programs written to provide information upon request, right? Or provide services to clients. We're just going to actually just look at some of those processes and do some, say, port verification and look at how things behave, and then that's really about it. So again, we're going to work in our CyberOps workstation for this one. So log into your CyberOps workstation as analyst. And we're going to work in the CLI. So we're going to open a terminal emulator. I'm going to make the window bigger right away this time. I still like it kind of, there we go. And the first thing we want to do is see which processes are running or which programs are running. We use the ps command. We're going to do it in sudo. So we're going to do it in root. So we start with sudo ps-elf. E says to show all processes, and the other two are formatting options. So L and F are just two different formatting for output. And CyberOps is our password. And here we see all the different processes running and what they're running as. Lots of them. But we can see here, this particular process, for example, is running as root. This one's running an analyst. So we needed to do this the sudo, sorry. We needed to type sudo first to see all the processes, including root. Otherwise, we would have only seen the process running as analyst. And just to see what I'm talking about as far as the formatting, we can do a -E and exclude the L and the F. And you can see the output's just a little different. We just see all the processes in more of a short output rather than a long format. Now if we want to see the process in a hierarchy. So when we looked at our Windows stuff, we saw that we had parent processes. If we killed the parent, then the children processes stopped as well. So our next step is to look at the processes and display the process hierarchy to see the parent and the parents and the children in the process. So then we just do sudo space ps-ej. E is for every, J is a jobs format, and H is to tell it to show it the hierarchy. Now if you look at it, you'll notice that some stuff's indented. That's how Linux handles or represents the hierarchy. So the ps command, the processes, the parent processes and the sub-processes or the children processes are represented through indentation. Now we're going to look at the different services running on the server. So, right, basically a server provides services to a client. So if we were looking at a web server, I think is a great example and they use it, it provides web services to clients. And we're going to use the netstat command to see which servers are running on this computer. So we just type netstat and hit enter. And here we can see we have got a lot of things going. We can see the different things that, the different servers that are running. And we may want to filter this some, and so they give us some different options to go ahead and filter this, so it's maybe a little bit easier to go through. We're going to type, so hit enter. We're going to use netstat again, but this time we're going to use it with some of its options. Oops, we got to run it as root, sudo netstat -tunap and hit enter. A lot less output, a little more readable at this point. Protocols, TCP or TCP6, the local address, the foreign, the opposite address, the state listening, our process ID, and the name of the program. So our process is 382, and the program running is NGINX, or we've got process 374. and the program is VSFTP, so this is our FTP, SSH, so on. So a little more readable. Now what you want to do is use your man pages to find out what these options mean. Now I'm not going to go through this completely with you because you can read it yourself, but if we do a man netstat, you want to find out what TUNAP options are. So if we do a man space netstat, and then we read through this, hit a space to scroll down. I'll hit enter here. Because our -N, we found that one. That tells me to show numerical addresses instead of trying to determine a symbolic host, port, or username. So we've got N. We still need T, U, A, and P, right? Here, we'll do P, and then I'll let you guys keep. P is for program, show the process ID and name of the program which each socket belongs to. So we saw that because I just looked at the FTP. So keep looking through this to finish it up, to figure out what all the other options are. A, since it's already here, shows both listening and non-listening sockets, and so on. So use the man pages to find out what the meaning is of T, U, N, A, and P, and I just gave you a few of them. And the order of the options isn't important. I didn't have to spell tuna P. We could have put those options in any order. So our first column here shows the layer 4 protocol, which we saw. And then we got 1, 2, 3, the fourth column, or it should be the third. Oh, I see. It's going to show the address and port format, so it displays the local IP address and the port on which the server is reachable. So we have port 80. Probably tells me I'm running a web server, right? It can be useful to cross-reference the information that you get from netstat with the PS command. So, and your processes may be different here versus the lab, so make sure you're paying attention to that. So we're specifically looking at port 80 here, and we're looking at the program NGINX. So for us, the process ID for that one is 382. So let's get some more information about the process ID 382. I think in the lab it gives you a different number, and it's going to do that probably throughout all of them, as far as there's going to be differences between your system and what they did as their examples. So just make sure you're always using your actual output. So sudo, we're going to look at the process of this server that's running, or service that's running. Sudo ps-elf, and we're going to pipe grep and then our process ID, which for us is 382, and hit enter, so that we can get a little more information about this process that's running. All right, so just some interesting things here. When we pipe through grep 382, it's going to show us all lines with the number 382 in them. The first one is our process that is 382, and the process running is NGINX. If you just do a Google search, you can see, or any search engine you like. To find out a little bit more about NGINX, it's just a lightweight web server, so we were correct, port 80. Someone could actually use that port for something else, and in fact, I think at some point in one of our configurations for our web server, we use different port numbers, and so that can certainly be done. You don't want to just make an assumption, but given that this is out of the box in a class, we can probably at this point make an assumption. We see this well-known port 80 on a server that we're running a web server, and that's what NGINX is. That's running as root. NGINX actually starts a process under HTTP user, which would make sense, right? Because it's serving up, it runs under HTTP for everyone that connects on port 80. And then this last one is actually you, right? Because you typed the command grep 382, and then that becomes part of the output. Because it was used as a filter, then that's the number. That's what you did here. So this is our web server running. That is the actual process 382. This is what the web server started up as user HTTP, and this is you as analyst when you typed the command. Well, lost it. grep 382. That's another place that 382, that processor, that number showed up, because that's what we're searching on, is that number. So next we're going to use telnet to test services, and if you've ever been in one of my classes, especially probably the intro-level network infrastructure courses like 133, 134, that's one of the things we talk about. If we want to see if a service is running, we can telnet, so we don't assume it's a connectivity issue, right? And so are we having a service issue or a telnet, are we having a service issue or a connectivity issue? And one way to see if a service is up and running is to telnet to its well-known port number. So we're actually going to do that then next. We're going to telnet to port 80 to see if that web service is up and running, and then we're also going to see how it reacts and behaves when someone tries to telnet to an open port. So we're going to telnet to this computer, so our local address is 127.0.0.1 to port 80. That's going to show us that NGINX is running on port 80, hopefully. It's always good about doing demonstrations. Hit enter. This is the output we're going to get. If it says it's connected rather than closed right away, then we know that that web server is running. Now what we want to do is send it some random characters that it just doesn't understand and press enter and see what happens. And what you get back is a bad HTTP request, and it responds in HTML. Now why is that? So the telnet protocol's clear text, the connection was established, you sent some junk to it, you sent some data directly to the web server. The web server responds with an error as a web page. So this is what you would get if you were in the GUI and you got a bad request. You'd see that 400 error. Now you're just getting it from the telnet session that's saying, hey, it's up. You sent me some text. I don't understand that text, so I'm going to respond to you saying, I don't understand it. And the thing is, the web server only speaks in HTTP protocol, so that's why you got the response the way you got it. Now let's use it for a different port. So let's telnet, sorry. Let's get in our window. Let's telnet to SSH, which we said we knew is up and running. So that was actually, I would scroll, but it's just a bunch of stuff. Way up there, that was one of our processes that was also running. So telnet 127.0.0.1, and this time the port for SSH, which is 22, and hit enter. And so now you can see, yep, SSH2, open SSH running, give it some junk, or type in some junk, and hit enter. And it doesn't know what to do, right? It just says protocol mismatch, and then it closes it. Let's try one more. Let's telnet to port 68. So just hit the up arrow and get rid of the 22 and put in 68 and hit enter. Now this one, it couldn't connect. So up here, we could connect. Here we could connect. But here it can't even do that. The interesting part about this is that telnet is TCP protocol. So it's a layer 4. It's a TCP connection-oriented based protocol. Whereas port 68 is actually a UDP protocol. And so it doesn't even open. That's it for looking at the Linux services and some different things that we can test. Some of the advantages of using netstat is that we can display our connections that are currently running on a computer. And I can take those connections, I can find process IDs, I can cross-reference them with the PS command to get some more information, as we did. We got our big listing, and then we said, hey, we want to pull out this process 382 and find out a little more about it, and we were able to do that. A lot of folks, telnet isn't a secure way to remotely manage anything. We should not be using telnet to remotely manage devices, but it works really well just to see if services are up. So we know that our protocol stack works, and our networking works on this machine. This just tells me, okay, was port 80 up? Is my web server up? Yep. Is SSH up? Yep, it was up. Now this just happens to be a protocol mismatch right now between TCP and UDP. So it's good for testing some things, but just not good for remote access. And that's it for this one.